Alright, what's up guys? In this video we're going to pick up with some more calculus here. It's going to be another integration practice video. And this is going to be example number 31 of the integration practice series. Right, sorry, I'm trying to adjust the lighting so I can make sure you guys can see my work. So hopefully you guys can see it. Okay, so we need to evaluate the integral x over the square root of x to the fourth plus 16 with respect to x. Okay, I see a potential here to do a u substitution. We could probably end up doing a trig substitution for this at some point, but right now we can't do it because we got x to the fourth. So what I'm going to do is I'm going to do a u substitution. I'm going to pick u to be x squared, and I'm going to differentiate it a little bit here. So I'll get 2x dx, and then I'll get 1 over 2x du is equal to dx. And 1/2 is a constant, so I'm just gonna bring it out front. And what's gonna happen is it's gonna get it down to the u squared here so that we can do a trig substitution. So that's the first thing I spotted when looking at it. So now I get the square root of u squared plus 16 du. Now we can do a trig substitution, but if you notice up here at the top, we could not do it right off the bat. So I would start with a u substitution first on this particular integral, and then I can do a trig substitution. And this is clearly, if you still don't know how to do trig substitution, I have so many videos on trig substitution, so I'm not going to spend a whole lot of time talking about the method in this particular example or in this particular video. I have other videos for that, so please check those out. Just want to kind of get through this one. This is clearly a tangent substitution. So remember, if I have the square root of, and also keep in mind that trig substitutions don't have to be under square roots, but most are. And if I have the square root of a squared plus x squared, or x squared plus a squared because addition is commutative, or if I just see a squared plus x squared or x squared plus a squared, then we do a tangent substitution because it basically says that x is equal to a tangent theta. Now, in this particular circumstance, notice how we did a u substitution to start. So instead of writing it as x is equal to a tangent theta, we'll use the variable u. That way, we don't get lost. But typically, you would use x if you need to start off doing a substitution or start off doing the trig substitution. So in our case, we're going to let u equal 4 tangent theta. Okay. And that means that du is the derivative of that, which is 4 secant squared theta d theta. So don't forget about the constant 1/2 that was pulled out at the beginning. And all you have to do is substitute all the stuff in. Now again, for my videos, I always go through the steps in great detail, as opposed to just kind of leaving the ball for you guys to dribble. I like to make sure I talk about or show you exactly how to get the answer by showing all the work. Whereas in an actual class, your professor will skip most, well, I won't say he'll skip it, but they'll expect that you could do it on your own, and they won't simplify most things algebraically for you. They're going to expect that you already know how to do it. But in my videos, you get more bang for your buck because I go through and basically show you all of the steps. And that's one of the reasons why my videos are often longer, because I don't leave anything out. And I think that's beneficial for a lot of people, as opposed to assuming everybody knows how to do everything. So let's just deal with the square root here. And so obviously this gives us the square root of 16 tangent squared theta plus 16. I can factor out a square root of 16. And if I take the square root of 16, I get 4. So that means that I'll be left with the square root of tangent squared theta plus 1, which I know can be written as the square root of secant squared theta, which if I take square root of secant squared theta, that's just secant theta. So after you did the simplification, this would just be 4 secant theta after we took care of the square root. Now, again, don't forget about the 1/2 that was put out front. A lot of times when you pull constants out, Lord knows I've done this, you could easily forget that you pulled them out. So make sure you kind of keep track of those. That way you don't get into a situation. And so notice what we have now after doing pretty much all of the simplification. Okay. Now, clearly the 4's will go away. And remember, this is secant squared theta all over secant theta. So that just leaves us with a plain secant theta there. So we got the 1/2 that was on the outside. And that just leaves us with secant theta on the inside here, d theta. Okay. All right. So we know that the antiderivative of secant theta is ln absolute value tangent theta plus secant theta, technically plus c, but we would have to multiply by the constant 1/2. So we would get 1/2 ln absolute value tangent theta plus secant theta, technically plus c, technically. Okay, so we're not done, obviously. So remember that when we did the trig substitution, remember that u was 4 tangent theta. Okay. So that means that tangent theta is going to be equal to u over 4. Now, hopefully you remember SOHCAHTOA. So remember, tangent, that's opposite over adjacent. And so since tangent is opposite over adjacent, OPP, ADJ, that means that the opposite side of the triangle is going to be u and the adjacent side is going to be 4. So what we're missing is the hypotenuse, which we'll need to find because we're going to have to, we're going to need the ratio for secant, which is just the, where we put this at, I need to be able to see it, so I'm going to leave it right there. Okay, so to do that, we could just use Pythagorean theorem. So remember, a squared plus b squared is equal to c squared. We already have our opposite side. We already have the adjacent side. So just plug it in to the formula and see what you get. So the opposite side here, what was that? That was u. So that's going to be u squared. 4 squared is 16. So this would be plus 16 is equal to c squared. And again, we're trying to solve for c, which is the hypotenuse. So if we solve for c here, we'll simply get c is equal to the square root of u squared plus 16. That's what we'll get when we solve for c. Hopefully you guys can see the light is going out a little bit here. Apologize. Hopefully that doesn't fall. Okay, so now that we have that, and again, you don't have to, I'm gonna put this in here, that way I can see it. You don't have to actually draw out the triangle, but it does help sometimes to draw a little bit of a triangle and just kind of get a visual of everything. So we know that the hypotenuse is the longest side of the triangle, or the side of the triangle that's directly across in the right angle. So you get the square root of u squared plus 16 to be on the opposite side. And we already know what the adjacent side is, and we already know what the opposite, I'm sorry, this would be the hypotenuse, excuse me. If I said opposite side, I meant to say hypotenuse. And the opposite side was u, and the adjacent side was 4. And why did that matter? Again, we needed to find that because when we integrated, remember we got secant theta, we got 1/2 ln absolute value of tangent theta plus secant theta. Well, we need the ratio for secant theta. And remember, secant theta, that's hypotenuse over adjacent. So that's why we needed the hypotenuse, because we needed secant theta. We need the ratio of that. So that means that we'll have the square root of u squared plus 16 is going to be the hypotenuse, and then that's going to be over the adjacent side, which was obviously 4. So that's why having the triangle drawn out as a visual may be somewhat helpful. Alright, so we go back to what we had. So we have 1/2 ln absolute value. And if we go back to what we had, remember tangent theta, that was u over 4. So we plug that in there. So that's u over 4. And then don't forget that we were adding that to the square root of u squared plus 16 all over 4. Absolute value of all that, and then plus c. And we can clean it up a little bit, simplify it. Let's go back to our original substitution. Remember, u was x squared, so we got to plug that back in and write our final answer. So our final answer for this integral, square root of, not square root, excuse me, x over the square root of x to the 4th plus 16 dx. So our answer to this integral would just end up being 1/2 ln absolute value of x squared plus 6, not plus 16, x squared plus the square root of x to the 4th plus 16. And we had a common denominator of 4, remember, so we could just write that all over 4. And you do have to add the plus c, and that will give you your solution. So let me circle that for you. So hopefully that one wasn't too bad. Again, how bad any integral is for you to evaluate is subjective. Kind of just depends on the individual and how good you are at the process. But hopefully that one wasn't too bad. We certainly worked on ones that are far more difficult. Alright, so that is going to be your answer. So let me know if you got any questions about it, and we can talk about it. But I'll see you guys next time.